This is a Motorola R-2001D as in Delta. This is a communication system analyzer, another name for a service monitor. I really like this one, mainly because the way the controls are set up, it's really easy to use, very intuitive. Unlike some of the monitors where you have a bunch of menus to go through and that, this is pretty easy to operate. This covers a frequency range of 10 kilohertz to 1 gigahertz, and it has a resolution of 100 hertz here. And it will generate any frequencies in that range. It has an output attenuator here that has 13 ranges, and also you can output through the output ports here FM 0.1 microvolt to 1 volt RMS and AM 0.1 microvolt to 400 millivolts RMS. And it'll also generate an FM carrier which you can modulate up to 75 kilohertz, so you can use it for commercial FM. And also you can generate an AM modulated wave up to 80% modulation. It has a sweep generator that'll sweep from 10 kilohertz to 10 megahertz. Has an input sensitivity of 1.5 microvolts for 10 dB synad, so it's pretty sensitive. And I'll do some on-air checks on here that'll kind of demonstrate that. For deviation measurement on FM, it has 3 different ranges here of 1, 10, and 100 kilohertz. And the spectrum analyzer section on here will measure from 100 kilohertz per division to 1 megahertz division, and it'll do that over a range of 1 megahertz to 1 gigahertz. Has an oscilloscope, which isn't very useful in my opinion, very low bandwidth, and I would use another scope. I can see if you're in the field maybe you'd want to use it if this was the only instrument you had. Has a digital voltmeter also that is, my opinion, pretty useless here. It'll do tone signaling. My unit has just a standard time base. It doesn't have the ovenized oscillator, but it does have the capability to connect an external reference, so you can use like either a GPS time base or rubidium standard, or one of these ovenized oscillators like I had in one of my other videos, which I think I'll do in this one. I'll mount one of those little modules in here. So anyway, I'll turn the unit on. The unit goes through a test, and then the display will come up here. I can focus it. And like a lot of service monitors, it has your frequency. In this, well, I'll put it in monitor here. It'll give you your input level, the error, frequency error, the deviation. This is an FM here. It also has, and this is what I like about this unit, is these up and down arrows here. You can toggle through the different displays here. For instance, this will measure modulation, duplex generator, RF memory. I like the spectrum analyzer. Now here you got 2 inputs on this. You've got an antenna input. This is high sensitivity that you can measure off-air signals, and then you have this RF in-out connector here. This one has a dummy load that you can transmit in up to 125 watts. This is for a low-level input. This is for a high-level input. Anyway, for off-air tests, you can connect up an external antenna. The frequency is entered on the keypad here. You use a cursor control here to move it across, and then I can enter a frequency. For instance, I'm going to enter 146,400. 46,400. And now I have a handy-talkie, 146,400. Test 1, 2. Here's a view of the spectrum analyzer here. Test, test, test. This unit has a problem with it. So far in testing this out, most of the functions seem to work except for one, and that is the RF scan control. When I turn this should vary. Let me move the cursor over here. This should vary the frequency here. When I turn the scan, I should be able to go up in frequency or down in frequency, and as you can see, nothing is happening. So there appears to be a problem. This uses an optical encoder inside the unit here, and that may be where the problem is. So what I'm going to have to do, I'm going to open up the unit and I'm going to test the optical encoder. This needs to send pulses to the microprocessor that changes the frequency here in the internal circuitry, the phase lock loops here. So next I'm going to open up the unit and we'll see if we can find out why the RF scan control doesn't work. So stand by for that. Well, this was a little more involved than I thought to rotate the front panel down. There's a number of screws you have to take out here and here and here. And likewise on the other side, you've got up here, you've got two long screws that go into the shield on the CRT shield. You also have to take this attenuator knob off because that stays in the unit. When you do that, this will tilt down. Be very careful. You've got these flat flex cables which tend to break if you look at them wrong. I was missing one screw in the back, so someone has been in here before. Anyway, here's the optical encoder right here, and I'm looking at some of the solder connections. I'm going to use a magnifier. I don't want to pull this out any farther than I have to. This front board is connected on to the main board with these blue connectors down here. So I should be able to remove, well, we've got some coax connectors here. There's a ribbon cable, two ribbon cables here. All these flat flex cables go into these edge connectors here. I wonder if I was really lucky, there would be a bad connection on one of those that resulted in the optical encoder not working. I don't know if you'd ever find one of these. Let's see. Soft Pot Digital, Los Alamos, California. 5 volts. It's got an A and B connector and ground. 4 connectors. That might be a standard item I might be able to replace. Anyway, this modular construction, you can see each of these boards come out. They're seated on edge connectors here. Really nervous about these flat flex cables. These things are very fragile. I think before I do anything else, I'm going to try cleaning these connectors. I may touch up these solder joints here, although the less I play with those the better. So I'm going to clean up those connectors. I'm going to power it up and see if I get my optical encoder running again. If not, I'll have to dig further, but the less you have to go into this, the better. If one of these flat flex cables goes bad, basically you got big problems. So anyway, I'll move forward from here. So stand by. I'm measuring the input voltage to the optical encoder here, and it is getting the 5 volts, but still no joy on the frequency change. So we still got a problem. I'm going to scope the data terminals on it. It's marked here, and see if I'm getting any variance. And then if it's working at that, and unfortunately the problem's somewhere else, so we'll have to investigate that. So moving right along. Well, the problem was on the connection here on the optical encoder, terminal B. It was not making contact, and I verified that going through the ribbon cable, or I should say the flex cable here, into this connector here. I had an open circuit, but now as you can see, when I turn the scan, the frequency is changing. So that function is back on. So now I'm going to put the unit back together. Hopefully it'll still work, and then I'm going to run a few tests on it and we'll see how it goes. Got the service manual for it here. This shows the optical encoder and the connections here. It's a 465 page manual. I'm going to print it out here, but luckily I was able to fix this just using the information on the monitor here, but it's good to have the service manual. Anyway, I'm going to put the unit back together and then we'll test it again, since sometimes things stop working when you put them back together. Got a ton of screws to put back in here too, so stand by for that. I got the scope on pins A and B of the optical encoder here, and I'm going to turn the scan, and here you can see the pulses produced. This is direct output from the optical encoder. Here's counterclockwise, and I'll stop, and here's clockwise. So you can see it's feeding the pulses now in both directions. Nice thing about this is it's isolated from the power line. This is these are handy to have, these little voltmeters with the built-in scopes in them. This unit does not have the ovenized oscillator option, but it does have an input on the back here for an external source here for a frequency standard. So what I can do is I can feed this in through this BNC connector with my GPS standard, and then on the bottom here it says "10 megahertz standard, internal, external." So it's on internal. By throwing this switch, that connects the BNC on the back to your internal time base. So that's what I'll probably do. Well, the unit's back together, so I'm going to power it up now. We're on standby, so now we'll hit the power switch. I guess that's a good sign. It's run through a self-test. Intensity should come up, I hope. And it's coming up. And it's out of focus. Everything got... I cleaned it up a little bit too, so... Alright. So, I got a handy talkie. 445.0. There, you can see the... Maybe you can see it. Up here. The RF scan control is working now. So I can put it on. Well, actually, let me just enter 445.500. Okay. Now I'm going to monitor. I've got an antenna. And I get nothing. Let's see, what are we doing here? We're on monitor, FM, monitor. For some reason, which I think is operator error, this shouldn't matter. It's on FM going through the RF in out connector, which means I've got to push this. Please attenuate. Now we can do that. Oh, wait a second here. Hello, test. Test 1, 2, 3. Oh, operator error. 445.0. I had 445.5, no wonder. Huh. 500 kilohertz off. Hello, test, hello, test. 1, 2, 3, test. Less than a watt. 1, 2, 3, test, test, test. Hello, test. 1, 1, deviation. Hello, a little over 4. Frequency error. Yeah, this might need some calibration. Let's generate a signal. Okay. There's 1 microvolt. Let's see. There's 0.2, 3, 4, 5, 6, 7, 1. There's 2 microvolts. See, full scale is about 2 microvolts. Test 1, 2, 3, test. Test 1, 2. There's the spectrum analyzer. It seems to be working. Oh. Hello, test 1, 2, 3. Oh, there we go. Whoa. 1, 2, 3, test. Okay. 1, 2, 3, test. 1, 2, 3, test. Hello, 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 hello. Well, that seems to be working. Hey, let's try. I'm going to extend this telescoping antenna. I'm going to connect it to, let's see, RF port, pull, antenna push. And then I'm going to go to a local radio station. And we want monitor. I'm tuning through the FM broadcast band.
9. Wildlife Research Scent Killer Spray Combo is just $9.99 after $5 rebate.
Anyway, better turn that down. Just for fun, I hooked up this short dipole outside. It's not off the ground very far. I'm going to see if I can pick up WWV. Put in 5 megahertz first. Don't hear anything. Let's go to 10. There's 10 megahertz. It's fading in and out here. You can hear it in there. Let's try 15. Well, that's a little better. Frequency error 8, 10 hertz, 9 hertz. It's bouncing all over the place. Not a good time of day to pick it up. It's about 5 p.m. Central Time.
At the tone, 22 hours, 17 minutes, coordinated universal time.
I can make it out. It's not very strong, but this antenna is not very good either. Anyway, there's WWV. Here's a 40-meter band. Picking up some stations on here. 7.137 megahertz. Lower sideband.
The thrust of the article was kind of subtle, and I don't quite understand it, but
It's coming in fairly good.
losing command of communication networks means that
Anyway, it's about 6 o'clock p.m. Central Standard Time. So 40 meters starting to come up a little bit. I think that'll do it for this one. I'm going to calibrate this against my other unit and then put it on the bench. So that's it for this one. Thanks for watching, and we'll see you in the next one. Bye for now.